Hey YouTube, what's going on? It's True Customs here. In this video, we're going to be taking this cast steel turbine housing that we got from a customer. We're going to be attaching a wastegate on it. And the angle that we need, we're going to need to use some stainless steel as well to come off like this and weld that in place. We got a little bit of a gap there, which, I mean, that's okay. But welding stainless to cast is a bit of a process. So I'm going to be taking y'all through that. Let's get into it. Okay, so the first thing that we want to do is make sure that we have everything marked out. I put some marks right here on it. We make sure we have everything as clean as we can possibly get it for what we're going to do. We got our spot cleaned out. We got a little valley groove made there. Because this is a twin scroll, we took the divider section that's in there and we went ahead and knife edged it. That way we have a smooth flow for the exhaust gases coming out to be shared on this wastegate. The reason, well, there's other reasons as to why we're doing it this way, but that'll be in a later video when I actually show what vehicle this is going on and everything else we did to it. So y'all gotta stay tuned for that. Anyway, there are ways to weld dissimilar metals. We can weld stainless steel to regular carbon steel like how we do when we do turbo manifolds by using our 309 wire. I think this is 308 or 309 wire. But when you're doing cast steel or cast iron, typically, if you use 309 or 308, it actually becomes brittle. So we're going to use a high nickel content. This is from Blue Demon. So you have a 3/32 one, and then we also have a 1/16. Not sure which one I'm going to use. Probably 3/32 because we do have a gap here. But we're using a high nickel content. Now what that high nickel content is going to do is allow for enough ductility in our weld so we don't get cracking. If you just use regular 308, that shit's gonna crack and break. If you use 309, you can get away with it. It's not the preferred method where you're gonna see you can use it if you're gonna see high heat, but if you're gonna see high heat and vibration, typically you want to use something that has more ductility, which is just basically like the stretchiness of metal. That way, this wastegate won't sit where we have it, and over time start to do like this from vibration and crack that weld. It'll allow it to move and kind of, I mean, it won't move that much. We won't really even be able to see it with the naked eye, but you guys get the point. So with that being said, we got it really hot, and what we're doing right now is we're actually preheating the oven. I'm just gonna use our regular household oven just to heat me, and I'm not doing any chemicals or anything like that in it, so it should be fine. This is not the preferred way to do it. You kind of want to make sure you do have a dedicated oven to stuff like this, but this is a one-time deal, so I highly doubt we're gonna get cancer from that. We're preheating the oven to about 400 degrees. After we get the oven preheated, we're gonna put this part in the oven, let that sit in there for maybe 20 to 30 minutes, possibly 40 minutes. And while this is in the oven getting baked so that the whole thing becomes around 400 degrees, one temperature, we'll be welding this piece. Just getting this flange set up here, getting this extra piece here welded, and this piece will be up to a good temperature. So by the time this comes out of the oven, we can weld this onto here and allow the entire thing to cool down properly. Decided if I'm going to use sand for the annealing process or if we're going to put it back in the oven and just slowly bring the temperature down, because what you don't, and the whole reason we're using the oven, you don't want this to cool down rapidly. If it cools down rapidly and uneven, you will also get cracks in your weld. The metal will shrink. When metal gets cold, it shrinks. When it gets hot, it expands. We kind of know thermodynamics, so if it goes too quickly, it'll compromise our weld and break it, or cause a fracture that we can't see, and eventually down the line, as our customers going through heat cycles on the dyno, on the track, on the street, whatever they're doing with the vehicle, it will start to compromise our weld, and it kind of makes our product a little shitty. So let's try to avoid that. All right, so we just put the the thing in the oven. And yeah, wish me luck on that, but we're gonna let that sit in there. I put the timer for about it may take a little bit longer than that, but what we're gonna do is we're gonna take our infrared temp gun here and we're gonna go ahead and just check everything, check a couple spots on it, make sure that the temperature is pretty even. And after we make sure that the temperature is pretty even all the way around, we'll go ahead and get everything fitted up to this thing. We just got done welding that. And once we get that tacked on, we'll go ahead, run our beads all the way around on it. And then I'll either try to use a bucket of sand to cool it down and then just wash it out really good later, or we'll put it back in the oven and just slowly bring the temperature down over like the course of an hour and a half to 2 hours. And then we'll go ahead and start test fitting it on the vehicle. All right, so we got our part out of the oven. Here, we're just gonna go ahead and hit it with our thermometer. And I mean, we didn't get it up to 400 degrees, but it might be a little too close. I'm looking through the camera here. But I mean, we got it a decent amount hot. About as hot as we need it to be for what we're going to do. Kind of didn't want to risk it with the oven because it's my first time doing something like this, and I kind of don't want to break the household appliances and shit. So we're gonna give it our best shot. We got already our wastegate with the pipe. This is still pretty hot. We already know that this has been pretty clean, so we're just gonna get right into welding it. Okay, so we got our wastegate weld, and man, this is a pain in the ass because this thing is so hot. And it's only like 200 something degrees, but with the TIG gloves, it's a little hard to kind of handle it and maneuver it around. We did 2 passes on it. What I'm gonna do now is cover the wastegate in some aluminum foil, and then we're going to dip this in some sand and then cover the rest. That way it can cool down evenly. All right, so this is so ghetto, but I had some sand for the powder coat machine, and I'm not using the powder coat machine right now. Granted, I don't have enough sand really to cover it the way that I want to, because I would really want everything completely covered in sand. And the sand will take on the temperature of the weld and the housing, and it'll kind of insulate it to where the temperature doesn't just escape the entire thing extremely fast, and it slows down the cool down process and allows it to be more even. So here is we just tried our best to cover majority of the weld because that was the hottest part, and hopefully as the entire thing cools down, it cools down evenly. And then take everything apart, take the wastegate off. I covered it with some aluminum foil to keep the sand out of the air and water passageways. The rest of it, we can just spray it all down with some compressed air, run some, run air through it and just double check and make sure that we don't have any more sand coming out. Granted, all of this is on the exhaust side, so I think that we're gonna be fine with it. And just take it apart, check the weld, see what everything looks like after it cools down. Okay, so now the entire piece is cooled down. We already test fitted on the car, but I took it off that way I could show you guys what we got going. So this is our cast iron. Mind you, I didn't do this, but I did do this right here. So this is our stainless, this is our cast, and these are our welds. We did 2 passes because we were starting to get some cracks, and I wanted to make sure that we didn't have any cracks in these welds, and that we got clean passes all the way around. It was a little bit tough to get back in that spot there because of the bend, and yes, we did keep the wastegate on it the entire time welding, just to help with the back purging as well. And to allow the whole thing to cool off, like I did say earlier, I put it in some sand. We didn't have enough sand, but it looked like that sand did help just the way that we needed it to, so that turned out to be great. And when we took it out of the sand, we just sprayed it with some compressed air, as clean as possible, that way we could get it fitted onto the car. So yeah, that's how you guys do cast iron to stainless steel, and make sure that you're using a nickel alloy. That's going to help with ductility and keeping it from cracking. So stay tuned to see the rest of this project and what car it's going on, and I'll end up posting like a couple pieces here and there on other things that I did related to this project. I haven't been posting a lot on this project just because I've been so focused on it, and yeah, I got a lot of other stuff going on, school, work, you know, the dog. But stay tuned, because that information will be coming out shortly, and we'll probably do like a little mini series in relation to this car and a dyno day. So you guys don't want to miss that. Like, comment, subscribe, hit that notification bell so when we do drop those videos, you'll be able to see them when they come out.